Oxides. This brings this little section to an end, and it kind of links with acids and bases because the oxides typically are acidic and basic and also react with acids and bases. So there are four types: basic, acidic, amphoteric, and neutral. Basic oxides, we've come across them before, haven't we? They're formed when metals react with oxygen. So this is called direct combination. Okay, magnesium, for example, reacts with oxygen. It burns with a very bright white light, doesn't it? Very intense, to make magnesium oxide. We did this reaction when we talked about empirical formula earlier in the year. So that is the equation. This is the oxide, magnesium oxide, and it's a basic oxide. Basic oxide. Well, what are bases? Remember, bases are proton acceptors. So they react with acids to form salts. You can finish that equation off. Magnesium chloride and water. And the astute among you will realize that that needs balancing. And there you go. Okay, so basic oxides react with acids. They're proton acceptors, just mentioned that. Other examples, well, calcium oxide, sodium oxide, group 1 and 2 metals, and some transition metals as well. Or transition metals in general do form basic oxides. There are some exceptions. Acidic oxides. So basic oxides react with acids. Okay, acidic oxides, you guessed it, are going to react with bases. They're formed when a non-metal reacts with oxygen. So classic is sulfur dioxide, the culprit of acid rain in its day. Sulfur, a non-metal, reacts with oxygen to produce sulfur dioxide. Once we have this oxide, which is an acidic oxide, it will react with water to form acids. So if I take, for example, sulfur trioxide and I react it with water, I get sulfuric acid. So acidic oxides react with water to form acids. Remember, acids are proton donors. And acidic oxides can react with bases to form salts. Slightly more complicated equation, this one. But carbon dioxide with sodium hydroxide produces sodium carbonate and water. And it's already balanced for you. Okay? So acidic oxides can react with alkalis and bases in general. Okay. Other examples: carbon dioxide, sulfur dioxide, nitrogen dioxide, non-metals with oxygen in general. Amphoteric oxides do both. They're formed when some metals, some examples of this, react with oxygen. So for example, aluminium reacts in that way to produce aluminium oxide. Right, great. Well, this aluminium oxide, just like some of its other friends around it in the periodic table, it can react with, if it's a metal oxide, and it's a basic oxide, isn't it? So it can react with acids. Yeah, great. But this aluminium oxide also reacts with bases. And for that reason, it's amphoteric. Now there, that's the aluminium oxide reacting with acids. So it's acting like a basic oxide there, isn't it? So it's reacting with acids. Okay, I balanced it for you. But also, it can do this. It can react with sodium hydroxide to form sodium aluminate. We saw this in the process of electrolysis and extraction of aluminium. In order to remove aluminium oxide from the ore, we use sodium hydroxide, and that dissolves the aluminium oxide as sodium aluminate. So we've seen that reaction before. It reacts with both acids and bases, so it's amphoteric. Two examples you really should remember are aluminium oxide and zinc oxide. The final example of oxides, types of oxides, is neutral oxides, and yes, you guessed it, neutral oxides react with neither acids nor bases. Okay, examples: carbon monoxide, dinitrogen oxide, and nitrogen monoxide. Okay. Right, a couple of pages to read and some questions to answer.